We are live, and as we went live, we just lost Emmanuel. Emmanuel, if you just hit a notification, whenever you're reading notifications, your screen turns black, which is what we're seeing right now. I hope he'll make it back. Okay, he's back.
Yeah. Sorry. Perdón.
All right.
Sorry. Yeah, my bad.
Yeah, we can't hear you and we cannot see you if you do that. I'm sure your phone does multitasking, but as far as the app is concerned, it'll drop you off of the stage. Well, so hello everyone. We are live. We are recording. This is a live discussion on clean code. So Emmanuel and I sort of interacted in a recent clean code discussion sparked by the Tech Excellence / Optivem crew by Yelena and Valentina. So I figured I would like to continue that conversation to some degree with Emmanuel. Emmanuel suggested I invite Mateus. Is it Mateus? Mateus? Which one?
Yeah, the first one. The first one is really perfect. Yeah.
Mateus.
Yeah, there you go. Yeah.
Okay, so Emmanuel suggested Mateus because the two of you wrote a book or are writing a book on the topic.
No, we wrote a book, and actually we also did a talk on the Tech Excellence channel about this.
that,
And
yeah.
actually, the examples are from them.
Mhm.
Like quality, the anti-patterns post from them. Like they're using not the example we used, like the patterns we shared that day. That's why I said like maybe it was a good idea to bring also Mateus because he will wrote the first version. Then I just helped with the second version when we publish it, and it was sort of like the thing we work on for a while. So it seems reasonable and fair to bring him and also share his thoughts on the things we were discussing on the LinkedIn post.
So what was the LinkedIn post was primarily about, writing silly tests or having some form of test smell. I think like that's the closest that I could describe it. And no book that I've found really covers, bad tests. I think only Kevin Henney actively talks about good unit tests. Kent Beck to some degree, but his work on the test desiderata like somehow didn't make it mainstream. So I commented on that post as, hey, this seems a bit contrived. Like that seems silly to the degree that it might be a little bit too obvious to pick up on. What's your stance on that? Like, is that still relevant today? We have IDEs who can pick up, right, on not having done assertions. For example, Mockito, if you use mocks or spy on something and you don't assert against it, it'll throw an exception. What's your stance on that? Between, is this a tooling issue? Is this bad behavior, code smell?
You want to go, Mateus? Want me to go?
Yeah, you can go first. Let's see.
Okay. Yeah. First of all, tooling. Regarding tooling, there are toolings that actually helps, and a lot of tooling that it doesn't exist. Actually, Mateus is actually working on some kind of linting for the test smell things related to assertions not being there. The other thing I've seen is people doing it for the coverage. I actually know someone in person that basically shared with me a code because the company they work for wanted 100% coverage, and they with reflection they got everything, all of the classes, just executing over them and not asserting anything just for the sake of doing it. Obviously, it's a silly thing. It doesn't give you anything, but people actually use it, which is kind of scary to think about it. So I would say it's not only two topics, but like the third one, like people using it intentionally for very other purposes than what we were discussing. And yeah, you also were mentioning like if it's something easy to pick up. I think it's also something easy to pick up, but also I guess it depends on the experience of the people doing the test in itself, which is another, let's say, peak of the, let's say, measurement we should keep on focusing on, right?
Mateus, what's your take?
Yeah, I think I agree with Manu because it depends on really Oh, I think it was Kentbeck who described this Ismail or even Martin Fowler, because this is difficult to sense. You know that something is wrong, or you see like, oh, this is not looks right,
Yeah.
and it even is hard. It's hard to describe what is this feeling, and it comes from the experience that you have, right? So,
Mm-hmm.
as much as you practice, as much as you touch the code, however, there is a vast. So I particularly with Manu. So I've been researching this topic for a few years now,
Mm-hmm.
and the tooling specifically for tackling test smells. There are some, but they are purely academic. So, for example, I believe that if we come here and say, which tool do you use to tackle test smells? For example, uh, probably you might not be using one. That's what the evidence or the things that I've been researching shows. And for Java, for C Sharp, I would say even PHP, they are like mature ecosystems, I would say. So they do have some kinds of things to watch for. But then when you start to dive into, for example, the JavaScript ecosystem or even the front end, but not the JavaScript like the backend or the front end,
Mm-hmm.
the things get even trickier, right? So the tooling do one part, but other parts are more difficult. So for
Mm-hmm.
example, if we talk about flaky tests, right?
Mm-hmm.
That's one of the smells or not the flaky one, but the non-deterministic tests,
Yep.
right? Which tool do you use to tackle those, right?
Mm-hmm.
How you determine that the test is not deterministic in the first place to automate, right? So I think that is one part of the question. But for sure, there are many things that we can discuss and see that the tooling help us. But I think that each programming language is in a stage, let's say, is different. Like the age is different.
Mm-hmm.
Yeah.
That's a great point. I never consider it from the perspective of sort of linting the tests. Um, no, it seems reasonable, right? To lint the tests because normally we would attribute it to some kind of workflow. I think with TDD, even hexagonal architecture, functional programming, you would you would always bring it down to is the is the resulting code, is the test testing something that is written in a certain way, so with TDD, or is it a pure function, right? So that would be the more functional decomposition style of writing tests, or does it follow a let's say more hexagonal architecture esque separation of which dependency is being excluded in the system under test and which dependency is being driven, right? So that you know, okay, 7 dependencies, I want to control one, the other 6 are a code smell, and that you would attribute to um, a development workflow where the test being hard to write would be a signal to that there's a design issue. But I've never thought about automating that. It seems it like I like that there are tools coming, but is it possible without constraining down the developer? Because I could say the test will be deterministic if the function being tested is a pure function, right? Like that is a guaranteed proof of determinism. Um, that seems to be easy to do, but probably annoying for 99% of the legacy code bases because most of those functions will not have functional cores that are pure functions or are deterministic. There are some movements to inspire developers to sort of think that way, but there seems to be a lot of resistance. Uh, what I see a lot is either process enforcing KPIs, so metrics that enforce or give proof or like some kind of like guardrails that a process is being followed. TDD, or if you push it to the extreme, TCR. Same thing with coverage. I think the example that we've quoted from Valentina, from Yelena, was touching on coverage. Like, so organizations that push any kind of coverage metric would incentivize this kind of behavior. Where does the developer come in here? Like, at one point, where would you say that this is negligence or bad behavior, or, like, okay, once is okay, but you should know better, like, don't repeat kind of mistake?
I guess we're getting into the point of maybe like the professionalism of each one, and because like that's, I guess, where you're kind of going, and it's kind of difficult. Also, I think you cannot blame your company only, or like what I mean is, like, you cannot blame the developers on your company because you also hire them. So my question is, what kind of hiring did you do to get that kind of
Sure.
professional? Then if you are worried about if the professional is the one that should be, then I would say, like, reflect on it and see why did you get there and what reasons and history was behind it. That would be the first thing. And the developer for me comes in the right, because and this is like a echo chamber for me. Like, I love what I do. I like spending time doing what I do. I do things out of my work time for this because I like it. I don't expect anyone to have that time or to share it. But I also understand that, like, as a professional, we need to keep sharp in what we do. So for me, it's part of my day-to-day professional lifestyle, which doesn't mean that it suits everyone. We also need to handle those kind of edge cases. There are people that, like, also need other stuff, and we need to understand, as much as it doesn't impact the work we do as a company, as a team. For me, that's fine, and we need to, like, try to do the check and balances. That's at least my take. I don't know, Mateus, do you think different?
No, yeah, I agree with you. And I think that even in the book that we wrote, because it goes, it says anti-patterns, but there is like a mix with the test smells. So a bunch of, well, that's what the attempt of the ebook to uh, transform those not only in testimonials, but what you can get when you do not follow TDD in a sense. But I think uh, that we also should recognize that we cannot make everything perfect from the start, right? So I do agree that we should have the guardrails. So, for example, Denis said, like, okay, which processes and tools and so on. So measuring the quality of your tests or your code base is always welcome. The code coverage, I think, should, well, and then it is an opinion, but I think it should be like the last metric, and we should aim for the ones that provide more value at the application and business level, in a sense. But in the developer, I think that there should always be a room for improvement. So, for example, we should be humble enough to at least to try to be a little bit better, or to write tests that are better, or try code that is better, and better in a sense that you provide the best value with the least amount of effort, right? So we are talking about the hexagonal architecture. So if it's a test, it's a test, and whatever that is, whatever it might be. One thing that I have observed while I'm working, I think that is we have this conversation, which is nice, but I still find difficult to see other developers that are not member of the communities as we are to adopt those. So it seems like there is, like, in the industry, there is like a whole, like, I don't know, vacuum chamber, and then there are the communities that try to keep pushing the adoption and improving, right? But the test smells, I do agree that we should use tooling to keep track of those. There are even empirical evidence, like research done, that it affects the understanding of the tests for developers. So the smells, as much smells there are, it makes harder for developers to understand the test, right? So this could be used as well.
I wanted to come back also to the question you asked, Denis, at first. You
please.
asked when developers should be.
I also
For
wanted
me,
to go back to that. Thank you.
no problem, because you asked when developers should be involved. I think if regarding tooling, there are certain things we can manage. Like you were talking about assertions, output. Well, there are like three types of assertions: output based, state based, or communication based. Meaning like those are the types of assertions we can do.
Yeah.
That can be automated, kind of related to other stuff like big setup, or like if the tests are deterministic or not. That's something where tools cannot help, or not help a lot, but in the sense like it will be hard to build a tool. Not meaning like it cannot do it, but meaning like it will be hard because it depends on many factors, not only the language but the testing framework, also the way you do the way you work with the test in itself. It also be an impact there. So it's really hard for tools to solve that issue. So I think in those kind of smells related to that, we as a professional should be really aware of it, and also what hurts us, what's the pain for us. Because if I run the test and sometimes fails, that's a have to relaunch it, then that's a pain for me. There is like a nice talk about Artistar that basically talks about that, the pains. And she mentions to instead of measuring things like getting feedback on retrospective, use like the pain as a driver for making change. What's most painful for you, then you tackle first.
Interesting. Yeah. When clean code became a little bit more popular in the I don't know 2010s, late 2010s, especially with the book with the third book, I think it was Clean Architecture and Clean Agile. That's where it really sort of started taking off. There was this dramatization going on, especially on social media, like Reddit, LinkedIn, Twitter. This idea that you're unprofessional if you don't do clean code. You're unprofessional if you don't do TDD. You're unprofessional, and I think that comes a lot from like Uncle Bob's stage persona. Like he just enjoys being a little bit more dramatizing. But I did notice there's a lot of let's say judgmental or like shaming culture going on regarding these practices, where either they're too hard on one end and then everybody says, and then the opposite side says, we're not going to do clean code because that's silly, because it's like a shame based principle, so we're just going to do the opposite. So they overcorrect in too far in the other direction. So clean code has these like principles and things you should do, and things that are necessary and things that are responsible and things that are, let's say, safe and appropriate. And then the opposite is we're going to do none of those things because it's silly. And I heard this discussion about event sourcing. I heard this about TDD, and it seems to be primarily fueled by rage baits, flame baits on social media, and then harvesting likes and whatnot. But there is something you said that reminded me of this, right? So you said that you do it on your own time, Emmanuel, right? So that you don't really enforce it in your workplace, but you kind of expect it. But that reminds me of that same conundrum of like we could just enforce it. Like we could enforce, let's say, TDD, and then people get angry. Now, I'm not saying let's, but I'm saying we could. Because I know a lot of developers who say they won't do TDD, or they will never allow it, or and I see this and I think, where did we go wrong in communication? Like where did the ideas are sound? Why isn't everybody? So if you're prompting ChatGPT to generate code for you, what's the likelihood that you would say, oh, and please follow clean code practices? You know what I mean? Like, at what point would you make it a requirement? So, if you're not making it a requirement, is there, like, can clean code and clean code practices be misinterpreted or taken too far that would create silly code smells?
Okay, this is a big topic, so I think let's cover it by part. Related to reinforcement, first of all, I usually when I have to look for a work, I always look for places where they already have those practices.
Yeah.
Because I've been in places where they don't have it, and fight it back is, well, you need a strategy, and the strategy to get it happen is not always easy, and they not always work. So that's like much easier. So you are in your echo chamber. That's why like you don't need to reinforce, because at least everyone has a base on that.
Yeah.
And then related to if we can reinforcement, I see it as a ways of working. So for me, it's kind of like my day-to-day stuff, like pairing, or I cannot, I cannot say like I see it differently. But I've been in companies where I actually been said that TDD is a toy, and what I actually identify, also re-identify this by doing the study, is that like some people think that it's a tool when they see small kata, small exercises, and they're not able to apply it in real life situations. And then it's like, okay, but this is a toy, we can use in these things, but when we're in a real project, we cannot do it. And it's like, okay, it's not that you cannot do it, it's that you are like, there is like when you are learning something that is like a J curve, and then you are like in the bottom part of the J curve, like trying to somehow get up, and the thing is like you will be there for a while until you can
that there
get
is
out
a
of.
risk associated, like an irrational risk associated with continued usage.
Yeah, and not just that, like it's like a dual process. When you get into something like it's a change, you get into the dual process, you have to go through the stages, and some of the stages are like, I don't like this. So that's what I see. And related to making us the make silly code, I think that, like for instance, what you're doing right now is like it has less impact than many other influencers that are sharing the opposite side of things, which I think is for me that's more harmful than the other part, because yeah, of course everyone needs to know how to do basic stuff or how to do like the basis, because it's important to know that, of course. But then when you share like an opinion, like a strong opinion about something like a clean code or something else, you are also impacting more people than the one you think, and that also have a really negative impact on the thoughts of others that don't have their opinion formed yet. So I guess that's why most people are in the other side. And then, as Mateo was saying, there's a hole between like why they don't apply these practices or see value on them, right? Maybe.
But it's interesting because a lot of people that I talk to regarding like pure, so most practices from extreme programming, so no estimations, iterative planning, cost of delay for planning, test-driven development, pair programming. The vast majority of people that I see this apply it wholeheartedly in production level work, they don't want to go back. They continue doing it, or they learn it at a very high intensity and they dial it down to 80%. They keep doing it, right? So maybe somebody learns TDD and they're like, okay, all the time, always first, a little bit extreme, but generally on the, let's say, the first third or like the first quarter of their investment time into building something new, most of that first quarter is test writing, even though it's not the first thing, right? So with a lot of peers and clients that I see this adopted, they don't want to go back. But if that's the case, let's say that's confirmation bias. How come it didn't pick up? Another topic, right? So if TDD is so good, if clean code is so good, why isn't it mainstream? Well, why are you elevating it? Looking for it at positions, job descriptions, because you know that like gives you a small signal of benefit. Why is it rare, you think?
Like if I use TD as an example, I would say, yeah, like I'm gonna look for it, but like I've seen the opposite with clean code and cyber architecture, and then people don't even how to spread this. Like I've seen that they become check marks because they were easy to achieve, and then it's like this is a check mark for a new job description. Like we need to know hexagon architecture, and then they put it in all the descriptions.
Yeah.
But practices that will be on my 8 hours that will give me some kind of security base on the things I build, on how I feel working. That's what I see lacking, and that's why I put more focus on them. Because clean code, you can achieve clean code many ways, but the flow you work, because you were saying why they don't apply TD. Well, TD for me is actually a flow, right? So it's my way of working, it's my way of thinking, and
Yeah,
and
you're
that tells me
validating product ideas before you touch code, essentially. Like you're
correct.
validating how well you understand what you're working on before you start, investing time into liable code, essentially.
And that's why I elevate it first, because for me it's my safety. What I don't want is I don't want to go back into somewhere where I need to write the code and then test in production. I don't want that.
Yeah, yeah.
I've been there. I don't want that. And
Mm-hmm.
I don't know if Mateo you think different, but like that's why I elevated to there, and I think let's say the sector doesn't cut it there because it takes time. It's not easy to understand. It takes time to practice, and it's something that is not being taught from the beginning.
Yeah.
Because they teach you how to do things, how to write code, but then when you go to TD, you have to unlearn most of the things you've done because the flow is completely different. So for me, it's kind of like why it's difficult for people. They're getting used to the flow they have. Why do I need to change? What's the benefit? Until they see it, that's what I think. Mateus?
Yeah, there is it's difficult to change, right? We experiment and we learn and we change, but I think this is because we are used to changing. So we see a better idea, we adopt, but it's not everyone is not equal. So the rate of adoption and rate of change, how one might accept change is different. But I think I would go a step of the other direction, I guess, because if you see, I think for people that write software or crafters, like we are, well, not crafters, but the people who write code, right? I think we have lost a battle with processes because if you have a look at a Scrum, for example, so now they are trying to pick up, but if you see the Scrum, it is a process. So the process is something that you can pick up quickly, right? Whereas values and practices, they are not that fast to pick up. So you see, like, uh, how long? I mean, I don't know, but for me, it took years to normalize to write the test first before the production code. And if you compare that with, like, let's say I'm proud of the work that I do, like to write code. I'm proud of it. But if you try to see like a relationship, and here is like my personal experience in the market. But if you see, I don't see many people proud of their work. So I see people that they are not proud of their work, and they jump, for example, to another position or to another whatever it is to the process because they see uh, the act of writing code should be something not to be proud of. It's something difficult. It's something terrible because if I touch something, I will break something in production, right?
And do you think
This
like
is
that pride is that like a form of regret for having created a legacy system, or knowing how to do it better, but they just can never get the budget approved or the time approved to go and fix it?
well, if well, I think the budget. So there is a triangle, right? The quality and the how fast you can be. But I think the time and money should never be an excuse to deliver well-crafted software. So, for example, if you compare that with other professionals, if you go to the doctor, you don't expect the doctor to not wash their hands, or you don't expect to not see a, I don't know, a well handle things or clean things to give medication to you, right? So this is a given. So I don't know why we do split that, right? So between uh, the software and how to do that, how to make this well done or well crafted. But this is one part, and the last one that I've been more closed, that I think relates with also the adoption that you mentioned, is that I see in where people get their degree or courses or boot camps or whatever. Now it's increasing, I guess, based on my conversations with those kind of industries, let's say, but university boot camps, they are giving people this kind of material, but it's not enough.
Yeah.
So I haven't seen yet one place that you can go and okay, I will have this signature, this subject. I will sign up
Yeah.
for TDD, right? Or
It's
even
also very
software design.
difficult in a kata setting. I always tell them,
Yeah.
one of the things I it's too academic. I like that you mentioned boot camps and academia, right? Because it's too academic, right? So it's very difficult. People always ask me for workshops for TDD or for workshops for refactoring or legacy modernization, and when I let them have full reign over the curriculum, they tell me they just onboarded somebody and they're working on a greenfield project on some add-on for some old feature that they have, and they want to do that, right? So they do the least critical, least important, lowest priority system as a greenfield microservice, and they want to do that as TDD. And I think that's where this is coming from. It's like, if you treat it like a toy and you'll use it on something that's not important, you won't give it the correct constraints to learn it correctly. Or if I put it differently, right? If I gamify it, right? So if you like playing a video game and the video game has huge opportunity for skill expression, where just by sheer determination and practice and learning how to perfect whatever it is you're playing, whether it's a fighting game or a shooter, but it has a lot of skill expression. Like, you can tell that somebody has played a lot and has gotten very good. If you're playing at the lowest difficulty, at the lowest rate of challenge, with the least amount of constraints, you will not get good at it. Right? So if you're hyper optimizing, just getting it done, getting it over with the least amount of constraints, you don't really get any benefits, and it's not really fun, and it's not engaging, and it feels like a waste of time. It actually feels like a toy if you start learning TDD by applying it to something completely unimportant. At least that's my experience. And alone, unimportant, low priority, greenfield, and alone, right? So not pairing or not involving business. Which again, TDD in isolation, I don't know. What do you think? Because I think TDD in isolation doesn't make sense unless you do the other extreme programming values. If you're not going to build something iteratively very fast in a lean manner, right? So if you're not focused on waste elimination, if you're not going to refactor your code as soon as possible, then you probably don't get the benefit from TDD. Right? Like, it's very difficult to tell to the business, hey, TDD allows us to refactor our code and to improve our design, if we're not going to do that. If by the time we get there, we're already busy with the next feature. So it also depends a lot on incentives, in my experience. Right? So if you're creating incentives where you're just churning out feature after feature, and you don't really control your work, you don't take accountability for your own priorities, you don't take accountability for being treated as more than just a programmer, as somebody who churns out code, then you'll limit your values, essentially. Like, they will speak your values more than whatever process you're following. And if you're following TDD rigidly without those values, I don't think it provides a benefit. And maybe our TDD conversations are a value problem, not a TDD problem, right? So if you don't value having responsibility for delivering working features that don't have bugs, and being able to prioritize fixing them over whatever the product owner wants you to do, then I think TDD, like, at least the benefit of it is diminished. of TDD, of clean code, of similar practices that require, let's say, a high degree of autonomy from a group of people. What do you guys think? Mateus, you have some. I see I sparked some ideas.
I mean, for me, it's usually the TDD or let's say the standard, the sensible defaults that we follow. So some things that are well tested, let's say, so proven empirically that they help you, is a sign that we can use them to make benefit and to follow what to do what you mentioned. Like, I think that is healthy to decide when to practice and when to not to implement something or to do something in TDD or without TDD. But this is, I think, it requires also experience, right? You should be aware of the consequences. But I think there are two main there are differences in two things that comes to mind. The first one is uh, it depends on the context. I think that you can benefit on learning TDD outside of a professional setting. So I think that's one thing, because when you're doing that, you're targeting a different problem and you have a different context. So you're kind of preparing someone for the battle.
You're
Right.
optimizing for your learning curve rather than business outcome.
Right. It is possible to do that without this learning curve. So there are also published work that this can work, but well, it depends on the context. Now, what I believe is what you mentioned about the business, right? The value for the business. But I never saw or I never been part of a project that did something without the DD and then throw away the code. So they did, okay, I won't do any test or do anything, but then I will throw away because it's a waste of time doing that because you didn't throw it. No. Usually, even in the clean, I think is the clean architecture shows like the curve, right, of maintenance. So basically, I think that's the big question. I think that a good point that you're bringing because it's difficult. I think it depends on the experience of each one, right? So to take the wrong decision. And the most important, the practice. I believe that the practice, the thing that I do is because I think that they help me to go to deliver the business value and to go faster, right? I think that's is the way that I see it. I don't know if Manu wants to give a take on this.
Yeah, I have. I was trying also to structurize what you, Dennis, were saying, and you were saying different things. So first, like business or product choosing more, having more value than the team. I think that's the key, because then you are maybe not thinking on the team as you should be thinking, and again, the company should be reflecting on what they want from the team. Because if they want a feature factory, then is the values they are having, and then the company is not trying to have. For me, like there is like a simple way of representing teamwork. You can work like in a line of a factory, which is how many people work.
Yeah.
Like I do this, and then someone else is going to do something else.
Yeah,
And
very
then
individuated, right? So
Correct.
it is like compartmentalized down to an individual.
And then you can see like when someone's rowing on a boat, they need to row together. If
In
someone
sync,
doesn't
yeah.
row, if someone doesn't row in the same direction, then the boat will spin, right? So that's how our work should be. And if the company doesn't see it like that, then the company or the culture that the company has is one of the problems, one of the root problems, I would say. Then you also mentioned like TBB brings also some values, but for me, like the most important value that provides me TBB is short feedback loops.
Yeah.
So understanding that if whatever I'm trying to build, maybe something is not going to be touched for like a certain time, but if it gives me the security that I'm going to deliver what I need to be delivering, and I'm going to be able to run the test and have regression testing, meaning like I wrote the test, and if I change the functionality, I know I have my hard list of tests that are going to cover me, then I'm pretty secure that I can deliver what I need to deliver. So for me, it brings value. I've been doing it alone. And in most of the situations, maybe not a POC, like if it's a if it's a proof of concept and it's going to be thrown away, and also understand that it's actually going to be thrown away, then okay. If the idea is that that POC is then going to become an MVP, then the things change, right? That's also one of the things I think as a developers we need to get sharp at, like what are the intentions behind what we're doing? What are we trying to build, and what's the company trying to go to? And those hard questions are also part of our job.
Yeah.
As Mateus was saying, like we don't expect to like go to a repair car shop or like anywhere, and they just do half of the work and then ask you, hey, I'm gonna do this and this, but I'm not gonna do the rest of the things because there's no cover on the bill. No, I expect you to clean the car or to do whatever you're gonna do it correctly. And if you need to do something else extra, I expect you to do it, and then you tell me afterwards, not the other way around. Otherwise, it's like a bit weird for me.
What inspired you to write the book?
Diego Mateus.
Yeah, so basically, the common it is in the title because it was common patterns. So of teams adopting the TDD, or especially teams that were used to not automation or automation after write the test after the production code. Right? So basically that was the idea. But I think when we started to work on that, it became like even how can I say, a collaborative work that we could like get from the community or people that was involved in writing and sharing that. So yeah, basically that's it.
Also understanding like what happened to the sector, because like the part of the book is also kind of like statistics of how is the sector actually at with the practice of TV. And then you realize like the lack of importance that company gave, or like certain things that are really important. It tells you how the landscape is for the field, right, and the practice itself. And for us, it was really important. We also identify like different kind of like parts, and that also somehow aligned to one of the things I was also working at the time, which it was like I was working on how to teach TV to people we work on the same company, and how to achieve it like in a structured manner. And I was like going backwards on my steps and talking to Mashukahar and at the time, and trying to okay, does this fit or match how you learn, and because that's how I did the work. And then with that we identify like we have like kind of different levels of learning, and then with that levels we match also like priorities of people. Like okay, if I'm on the first level, I may see this as a toy, or I may don't even understand what the tertiary strategy is, so I cannot move forward. And that also tells us how the landscape is, right? And also that move us to do another kind of work, which is the state of TDD that we worked this year, and we will keep working, I guess, next year too, with the help of I forgot the name. Damn it, Jitter, the Jitter Dev, because he's his channel. And we will work next year also with his help to improve it and to get more feedback of the community, not only from Europe, also from the United States or somewhere else, to see if we can also move that part.
Yeah, I see Ted trying to gamify. Like he has those cards. I don't know what he calls them, like the TDD
game.
card
game, yeah.
Tabletop cards. And he's streaming on Twitch regularly. To create, I think, a web version of that experience. What's I'm looking at your book right now, like the different levels, level 1, level 2. It seems there's a lot of bad habits on level 1, which mirrors my. So I'm looking at the nitpicker, the assertions, the assertion libraries, the hero definitely resonates with me. I see that a lot where there's a few people trying to for shit, almost over evangelizing it to the detriment of the team. What's your like socio-technical take on like which TDD adoption will be difficult, and there are things that developers are doing that will make it needlessly difficult? Like, what's a awareness test that you would recommend people? Right. So, if you're aware of what you're doing wrong, it might be easier to take action instead of take a breath and, okay, hang on. This is, you mentioned the best benefit for you, Emmanuel, is TDD gives you fast feedback loops, but you need to force yourself to stop work regularly and to give yourself permission to be wrong and just check, hey, I'm on the right track. Because I see a lot of people go wrong adopting TDD. They write the test and then they stare at the screen for 40 minutes. And it's like, which is the same thing, which is the same experience I see C++ developers do when they write something and it's seg faults and they open the debugger and then they stare at the screen for 40 minutes, right? So there is a lot of human agency here. Like, it has to come from you. Like, the process itself doesn't make you work in short steps, unless you're doing TCR, which I think was Kent's idea there. But it's even more extreme. Adoption is even lower. But it is funny. So if you're trying to help a coworker without micromanaging them, without sort of being too much of a smartass, just help them be self-aware about, hey, these things that make TDD difficult for you, like, you are contributing somewhat to that. How would you help them as best as you can to improve their self-awareness, let's say, of their awareness of what bad patterns they might be doing unconsciously?
The thing is, Mateus and I, we also work in the same team, so I think we also have done it. So what I'm saying that maybe resonate to you, Mateus, too. First of all, pair programming helps always. Why? Because and also, like, if someone is not proficient doing TDD and is with someone that is proficient doing TDD, that will also help the other person. Not because it's a smart ass, but because of the experience doing it. That also helps. And then on the pairing sessions at the end, we had like a short 5-minute break where we basically give us feedback about the day. And if we see something that is like really big and we need to share, or we see some part of the code that has been worked like this week or the past week from other pair, or maybe us pairing another task, what we do is like we gather together. I remember that Matteo that did that one day. We gather in a room and basically we talk about it. Okay, we've seen this, and this, and this can be wrong because of this and this, and then we have to pay attention. It's just raising awareness as a socio-technological tactic. I think works really good because it's not blaming. We're talking about the team, the shared code ownership, and also I remember that like we didn't do it on the first iteration. And at first you may don't agree with the thing, but then we have like what we call disagree and commit, which is basically, okay, we don't agree with this approach, but we're gonna go forward. And then at some point we iterate and see, okay, that thing that we tried is not working as expected, and we need to iterate over it, right? And then with the team and the second iteration, then we talk, okay, this went wrong for this, and this. We shouldn't do this anymore. We should try another stuff. That's what I think works.
Mateus?
Yeah, I think that was well summarized. But a recent experience that I had led me to, well, there are one thing that I would like to share. The first one is to recognize that we will write the code ourselves, like these bad, let's say, bad habits or bad whatever. We wrote those ones. So just to make it like, okay, it's fine. But to go, well, I'm assuming that the person or the team are not like assholes, right? So taking assholes out of the equation, because I don't think that we should tolerate them, but just go along with them. So see where they are, like share. Do not bring like every. That's what I know. So that's what you should like already know to like dump everything, right? enjoy the ride. So be with them. So when you see like there's something that can be done better, so oh, look, there is this. You're doing like this. Oh, let's try this. Look at this. This might help, and then go from there, right? And that might work or might not. But yeah,
I
Another thing
see.
that also, oh, sorry. Another thing that also
okay.
worked and may also help is like when we were consultants, one of the things we said is like, okay, if they want to go against the wall, we can prevent that to happen. But if we said it once and they don't listen, then just let it hit it against the wall. Then we'll be there to pick them up and say, okay, let's do it different next time. So instead of telling them what to do, it's like, okay, they want to do this, they want to do this. And instead of like talking about what they did wrong, talk about the pain. So let's say if you're having a difficult setup and they're like going for it all the time, and when it's kind of difficult, and we're like 30 minutes doing it, it's like, okay, we've been 30 minutes here, we cannot make it. Do you think we should pivot? And then you start putting the
Mhm.
pressure on the pain, not on the what the person is actually trying to do, to not make it feel like the let's say the object of the thing that is actually going wrong.
Mhm.
That's what we also try to do sometimes.
Does the book have a website? Mateus, I found your blog. Is that the main website where that you?
Yeah. I think we haven't thought about a website. There are some blog posts for sure. There are the book itself that you can find if you search on Google.
Yeah, so the book is
Common
called
3D into
the
patterns.
book is called Common Patterns That Make 3D Harder.
Yeah, and I think that's it. I don't know. Yeah, but we also have the well. Yeah, I think we don't have like a. That's a good point actually. But yeah, we don't
No,
have a website.
we have it
So
in Amazon actually. If they
If I
want
want
it,
to link it, what would you say the
no,
best
yeah.
short link would be to find the book quickly?
Google.
That one. Okay,
You're
thank
muted.
you.
Yeah, that you're muted. Ah, you shared. Okay, you shared. Okay.
Okay, awesome. It'll show up in the in
You're
the
mute.
in the in
that's if
the
you want it
blog.
for Kindle. But then if you want to read it like in PDF, there is also like a website, and also part of the results are on the well, it's in a Git, not on the GitHub. Yeah,
Mm-hmm.
so should be. We also have.
Awesome.
I'll share the other one for free. Like if you want to read the PDF and you don't want to go to get the Kindle version or anything, you can also
Mm-hmm.
download it.
I think there is like a version in ResearchGate as well. But for
Okay.
free. Yeah.
Is there anything else? Any questions that you would like to hint to the audience? I see we still have Raul, Tony. Hey Tony, Alberto, Pablo. So some of my friends, some of your friends. Anything that you would like to highlight, ask,
I'm
share?
actually wondering if they have any questions or they would like to know something because we've been talking for like an hour
Mm-hmm.
about what we think, but like maybe they have something else to
Yeah.
add to the conversation.
So for the audience, if you have any, maybe you don't have any questions, but if you have any 3D stories to share or some insights, now would be a good time. I think we'll be here for another few minutes. Which is a good time to make your presence be known in chat, so you get an opportunity to share your experience, what you think of clean code, of TDD, of tests, of code smells in tests. If you have any insights on that, feel free to share, please. I am also watching us on the desktop Substack app, which is new, and yeah, and it's quite sexy. Like we're in 16:9 format in landscape mode, and there's the three of us right next to each other, which is very different from what I see on the mobile
On
device.
mobile.
So yeah,
How did you get it?
but it's great. I like that the platform is experimenting, and we managed to. I think we had 15, 11 right now. I think we had 15 uniques on the stream today, which is pretty cool. Which is a huge step up from LinkedIn, from like an impromptu LinkedIn live. And the chat experience seems to be quite well polished. At least I can see when people like and I can see when people join. That's very helpful. That's something I miss on LinkedIn.
the only thing I think that like I really like this setup and everything. I wanted to try now the app to see how it works because I actually think the Substack is really a good platform for all of this. I think they're better than many of the others actually.
Yeah.
Surprisingly.
Yeah, I think they were one of the Substack was surprisingly a very good disruptor to the market. Like I saw LinkedIn is trying to do something TikTok-esque. Twitter has been trying to do like Clubhouse conversations, and it's very difficult to translate it into a video first platform where predominantly you would expect that from YouTube. But not everybody streams in a YouTube compatible format, or even in a YouTube compatible quality, or in a topic that you would be able to sort of pick it up organically on YouTube. Like it's very difficult to stream. Like there's a reason why, let's say, gamers, for example, or even Ted, you mentioned Jitter Ted, he streams on Twitch because it's an amazing platform for like hooking in bots and running polls and engaging interactively with multiple scenes. Even though YouTube has live streams, it doesn't translate that well into that platform. Just of how like the chat experience is a little bit more delayed. It doesn't feel like live chat. It's being sorted differently, etc. Javi has rejoined us. I think he joined at the very beginning. Hello, we're just wrapping up. I'm so sorry. You joined us in the last few minutes. Yeah, so thank you for everybody who was here today, and especially to the two of you. This was a rather impromptu, spontaneous, let's say, meetup that we've organized since last week. It's been a pleasure. We are hosting, so Adrian and I are hosting Nick Shoemaker tomorrow. So if you, the two of you, or the audience, enjoy this conversation from a more, let's say, I think it's fair to say that the three of us are a little bit more back-end oriented. If you would enjoy this kind of conversation on the front end, Nick Shoemaker is hosting a stream with us tomorrow. He'll have like a live coding session for TDD and clean code in Next.js in React. So React TypeScript is going to be the focus tomorrow. And before we close off, Alberto has a question.
Yeah.
What technical skill do you think is most needed to apply TDD as a workflow? What technical skill?
It's hard for me.
So there's a list, right? There's a list.
Yeah.
So refactoring probably high up on the list.
But also like testing knowledge is really important.
Testing knowledge.
But not
Code
only
smells?
for me, yeah, code smells too, because you need it for refactoring. Also test smells because you need to refactor your test too. Then also you most likely need design, at least some knowledge of design for being able to identify certain and how to build them. And I would also like maybe comment like this is not a technical, but for me it's really important, like having the patience and like also like the ability to stop and know where you are, because sometimes we get into the flow and it's like I need to stop. What part I'm in red, I cannot do refactor. I need to, and I think that's hard.
That's good.
I know, Mateus.
This is gonna make a great LinkedIn post, by the way. This part. Mateus, go for it.
No, I think that was answered already. But here I think it depends on what he meant by correctly. Because for that I would be a little bit pragmatic. Let's say like just programming. So if you know how to program or write code, give it a try. But for the work, well, it requires more training for the start. But then if you want to go big, the thing that you guys mentioned is like is a must.
But I was also gonna add like historical context. That's for me one of the keys for understanding what you're doing and what you're building. Like most of people don't know where test doubles come from or where they were built, and they don't see it as important. But actually, it's important to understand things like people talk about, oh, let's do an integration test. You're doing TD, and you're like, okay, let's do an integration test. Okay, an integration test because we have the pyramid and we have this testing study, and it's like, okay, but the pyramid was built before 2008, more or less, when the test doubles were coming up, and it came from before that. which means that integration test for them means having a big system, because test containers didn't mean nothing at that time.
Yeah.
So
Yeah.
understanding the context of when something happened gives you the understanding of, okay, this is something or when someone is talking to me about this, they mean this, and then I can apply these tools and these other tools that make sense on this environment too. And I think it's like a misunderstood skill. I would say.
I would even say pair programming to some degree. If it is a technical skill. Oh, Mateus, you need to go. Okay, I just saw your message. Sorry. Thanks for joining. I would just add to that pair programming as a core skill, I think, is very important. I would consider it a technical skill, like how to code live with another human is, I think, a very important technical skill. And then also how to code with a non-technical person, how to ensemble or mob with somebody who controls the product requirements, or with a tester, or with somebody who can give you feedback outside of the technical domain, right? So maybe feedback on the product, maybe feedback on readability, maybe feedback on, I don't know, enterprise architecture. I think those are all very useful skills. To expand a little bit on Alberto's question, and also some element of, I'm not sure what term to use here, but like function decomposition, right? So either typing systems, if you are working in a language that has types, definitely type decomposition. If you don't, then I would say, if you were working in a dynamically typed language, or a more like loosely typed language, if you're in the Python 2, Python 3 era, or PHP, or JavaScript without TypeScript, I would say functional programming, I think, is very useful. Most of what you can see in solid empirical evidence for good testing practices, I think Sandy Metz summarizes them very well, and most of her advice mimics the entire hexagonal architecture movement very well. When it comes to, like, you need to understand: am I testing a system that produces an output? Am I testing the inputs and the preconditions that go into the call, or am I testing side effects? And then, is the system that I'm testing so large that it does one of these things in a very orchestrated way, or is it a mesh of these things? So if you're able to identify just by looking at the design of something, like where you are, is this going to be pure behavior? Is it predominantly going to be checking side effects? Or is my input into the system also through things that have side effects? Like mocks returning mocks. That's a typical no-no, but which would prompt you to extract a functional core, or do some form of hexagonal architecture, like do some kind of split across a input seam and an output seam, or some kind of drivers. I think that's very important, and it's very difficult to really hone down the literature. That seems to be one of those in between knowledge spaces that are not well defined, and it's usually an overlap between Java understanding, framework understanding, and object-oriented programming, and then the disagreement can be very very, very loose along that chasm. Mateus said, there's a big hole in between. There's these simple concepts from Ken Beck, Uncle Bob, Michael Feather, Sandy Metz, and there's this big hole of confusion in the industry. Yeah, I think some element of functional programming would help everybody in the software industry, especially if you find it a bit difficult to write tests. I think the functional programming style is coming from what is set calculus, and it is coming from this idea that, hey, if I can prove that it is correct, it probably is, and you can write code in such a way that it is easier to prove correct. And I think that's what most legacy systems struggle with, is that they have been written in such a way that they are difficult to prove to be correct, to be working correctly. which is what we would in more empirical style say, hey, this system is hard to test. Right, so it's hard to put into a test harness.
And there's like the need of the think on what you need to test. Like you cover again like many topics like the functional core with the external shell of like that would be a good solution.
Yeah.
That would be a good solution for what you were mentioning. Also, like you were saying, the linting or linting or typing system, and for me that's like a circuit breaker there. Like I don't know if you've seen like Kenzie Dodd's like the trophy, right? He puts static analysis there, and for me it's like, okay, if I see a test, what is actually a test doing? It's exercising a behavior. Is the typing or the linting actually exercising a behavior? Actually, it's not. It's giving me feedback, short feedback about what I'm writing, not about the feedback I'm doing. So I cannot put them on the same level. They provide me feedback, but they're not meant for the same things, right? So like that's also important, and I see the difference there. That's why you can put it in a testing strategy, don't put it in the shape with the same level as at least for me, for instance, because they don't do the same. It's like trying to measure apples and bananas. They're not the same. So.
Yeah, the compiler is very powerful. Like if you have a strong compiler that will give you a strong error message, then you can design your code in such a way that if it doesn't work, it doesn't compile. That is also very good feedback, and it is also one of the fastest forms of feedback because it is feedback provided to you in almost every medium. Your IDE will scream, your interpreter will scream, the binary will scream, the test harness will scream, right? So it is immediate feedback from everywhere. So if you can rely on your compiler, rely on your compiler. The issue with the compiler is that usually it generates very verbose messages. If you come from a Java background or a TypeScript, TypeScript notoriously gives terrible typing errors, where sometimes it's just multiple screens plus a stack trace, and then I don't know, somewhere in there. But it's wasting your time, right? Because then you're just staring at the screen, and then you need an AI interpreter to make sense of the error, where a failing test might be easier to sort of limit your cognitive load on the right area.
Wanted to mention, like you mentioned, like functional programming. There is a book, Grok Simplicity, that I was reading with some friends that you know also actually, Cardo and Angel and many other people that also from your reading club, or they were in your reading club in the past. And those book actually is really interesting because like the first chapters, I haven't read the whole book, so I don't want to talk about the whole book yet. So the first chapter is really interesting because they separate the things into actions, calculus, and data, and then that actually kind of help you understand like separation of concerns.
Yeah, very separation of concerns. It's very reminiscent of event modeling. So sorry for
no, it's okay. Cool.
Event modeling, it's the more I lean into it, the more I see that event modeling is a valid non-TDD style of building software that provides exactly the same benefit as TDD. Like a formal method of writing code where you're expressing like BDD compatible slices, but the event model, if you're familiar with it, like it's a more decomposed form of event storming, but you're not really looking for enterprise architecture concerns. You're looking for like data transformation workflows, because that's the stuff that can break the most, right? So either timing of side effects or side effects of data transformation, and it's basically forcing you to work in so small steps, right? So it gives you the same benefit as TDD, which is working in small steps. So it forces you to follow a how would you like a non-homogeneous path. You do a data transformation, then you do a side effect, then you do a transformation, then you do a side effect, then you do a transformation, then you do a side, and it forces you to think about your system this way, so that you can never do both at the same time. If you are doing both at the same time, you're probably doing some kind of trigger or some kind of cron job or some kind of automation in the background, and it can really simplify designing complex systems with only a very few rules, which is very reminiscent of TDD. And rather than forcing you to do it at the testing stage, you are doing it at the project management stage, which is very interesting, right? So rather than doing this, the TDD style of writing code, test implementation, test code, refactory implementation, rather than doing it in the IDE with another developer, you're basically just isolating yourself to the test list, and you're doing it in the project planning phase. So as you're planning the project, you're like, okay, what does the walking skeleton look like? Okay, we have these we have these data transformations. Okay, that one's too complex. How many steps is it actually? And you get down to an equally uniformly sized step, so that you can see how many uniformly sized steps it will take to build a walking skeleton of the system. And then you can decide which ones to do first. You see the deltas from each step, so it's very easy to say, okay, we'll start at the middle, we mock everything that's on the left, and then we basically just focus on the part that the user sees first, and then we work backwards from that. I see a lot of people like hate on event modeling / event sourcing because of its inherent complexity, or CQRS. And then I see a lot of the same hate coming from the TDD community. But I see this as like orthogonal or even complementary practices that can bring like working in smaller steps closer to a developer through a few simple rules. Because if I just tell you to work in a smaller step, like, it's not gonna, like, yes, but how, and the how is usually, well, either do event modeling or TDD. Like nowadays, that's my recommendation. So to expand bonus time on Alberto's question, maybe look into event modeling. Maybe your project plan is humongous, right? Like every story has like, the acceptance criteria for a story is you implementing something that needs 100 tests. Maybe that's where the issue is coming from. So maybe give event modeling and TDD together a try, because maybe your planning incentivizes too large of a batch in between some kind of like incentive exchange or accountability meetings. And then that disincentivizes you to take a too small steps, because otherwise the project might seem gargantuan. But maybe that's actually the problem, that maybe that's the feedback that your process is giving you, that you're sort of resisting.
That's actually interesting, a good tactic for reducing the unknowns.
Yeah, because a lot of agile and Scrum or even agile coaches, they say whatever workflow you follow, the thing that will make or break the process is how you're slicing tickets. And then they don't explain how to slice tickets well. And I think that's what TDD does very well. Like, you have to slice it down. So if it takes me more than 15 minutes to write a test, what I'm working on is non-trivial, right? So if it takes me more than an hour to break down a system that I want to implement, it's probably not going to be done in 2 weeks, right? So like these things, like the inverse is not true. If it was very simple to write down, it might still take me a long time to get it right. But if I cannot possibly write it down in a simple way in a short amount of time, the implementation, the testing, the verification of whether it is correct is an expression of that complexity. Like, there is a correlation there. And I find that if you can't slice tickets well, just do event modeling first, do event storming, do DDD. But I would lean towards event modeling, and just talk to your business in the terms of, hey, hold on. Like, explain everything to me first. Like, before I give you commitment, explain everything to me first. And if that takes, 2 full 8-hour work days of meetings, maybe what you're building actually takes a year to build, and you're not even interested in building it, because maybe it doesn't match and doesn't fit your constraint. It might not fit your budget. It might not fill the skill, the skill completeness, the shape of your team. It might require skills that you don't have, or that you might have intermittently. It might require a full-time availability of 2 backend devs, and maybe you have only half. Or maybe you have one full stack developer and they're mostly working on front end. Those are all important considerations. Not technical, like, to echo on Alberto's question, these are now more socio-technical product engineering matters that are important. But yeah, but definitely code smell and refactoring, like those are. And refactoring in a legacy system. If you can master that, the sky's the limit.
but not just that. Like also focus on the small practices of, because when we use ATD or we say design, there are like a lot of things underneath, like frequency you make it, triangulations. So get all those things first, small stuff.
Cyclomatic complexity, code smells, function
Exactly.
purity if you're into that, or or type decomposition if your type systems supports it.
Object calisthenics also is a good thing for like the design part. Also understanding mutant testings, consents. Like maybe you don't use it, but understanding how it works, they will give you somehow a good understanding on how coherent and coupling and cohesion are actually related to each other and how they. Yeah, like I would also say like put more focus on those things. And for me, like the missing part of all of the is, you were saying like the legacy part, which I agree. Like that's one of the things that most people are like. That's why when I talk about it, that's one of the things I leave to the last thing, because I want them to start like learning basic things so they can move forward. And then when they get all that, the other part is much more simple to learn. But I also put after that also like architectural things like event sourcing, or like trying to build something with it and use the design skills you have to try to do something with it.
That's interesting because I like to do so in my work. I work with teams that are sort of stuck in legacy systems, and I try to be very transparent and upfront with intensity with them. Like if it's gonna be intense, I would rather upfront the intensity, and we sort of make sure that that's appropriate and what like what the appropriate level of intensity is. So I like to not, and it's very effective when the team is pairing. I like to not sugarcoat around this idea of let's learn it first and then apply it, but rather level with the team, like meet them where they're at, and then try to make like what does TDD in your messed up legacy code base look like? Like the critical parts that you touch often, what of that can we do with TDD, right? So how much of what you would normally do every day can we TDD, and how can we make that number just go slightly up rather than starting in a clean environment, right? So I would rather start with them in a dirty environment and teach them, well, where are the islands of cleanliness here? Let's expand those. Let's anchor in. Let's create strong platforms in areas that you know, and then build bridges in between them. And I use this is very very unknown. I had a conversation with Valentina today. Bill Ward's technique, which is Bill Ward. You might know him from Industrial Logic, but also a extreme programmer. It's this I3 technique. I just need to check what the I's stand for, because it's been a while since I quoted him. It's isolate, improve, inline, which is a very interesting technique. I use it a lot with self-shunting tests. This is Alistair Cockburn concept, right? Where if what you're testing is hard to express, but you're a very good debugger, you're used to testing manually, you're used to using the debugger in production, and you love tracing logs, because that's all you've left with, right? If you're not doing unit tests, then you're very good at the other four. Then I like to lean in to writing tests in such a way that we reverse engineer creating tests from the skills that the team is really good at. So I will tell them, well, debug this system, but let's do it in such a way that where you set your breakpoints is where we start writing a test. And I love doing this in JavaScript or TypeScript because it has the debugger keyword, right? So you write debugger, and it is basically a compiler macro that if you're running the code with the debugger open, it'll create a breakpoint where you wrote. And I always tell them, if we use a self-shunting test with that in isolate, improve, inline, then the code I want you to test, even if it cannot be put into a test harness, I will create a test that will spawn up the entire system, call that code, and then we'll start the debugger there. And then everything you look at from your debugging process, I ask you to, rather than in the watch window, bring it into the test, then write an interface for that, and then express what you're looking for in the debugger window in the test, and then extract everything that necessary to provide that information, make an improvement there, check if it works with the test, and then inline it back. So at least the change that we've made, even though the system is not testable, we had to spin up the entire thing. Even though the system was not testable, we have for a brief moment test covered the change that you wanted to make. And then they gradually learn this concept of, okay, but when I do this, then this makes me delete my tests. And then gradually they come to this realization of, well, if I just wrote my code this way all the time, then I could keep my tests, and then we produce less waste. So they go from like a net positive improvement to a slightly bigger net positive improvement, and it sort of creates like a gamified like system where they can lean into the skills that they have strengthened, right? So like their unit testing muscle has atrophied, but they have everything else is stronger. Like their debugging skills, their logging skills are much better as a consequence. So lean into that. Another good example that I've picked up from one of those many 3D talks is if you are logging, like if you have log statements in your code base and you're testing something with a side effect, convert those logs into events, like you would for OpenTelemetry, and then expose the OpenTelemetry bus in the test, and then unit test against the OpenTelemetry log, right? So if this was called, then this log should have happened. And that is a very good short circuit on how to get these kinds of teams to get into unit testing very quickly, just by exposing, and structuring their logs better, and then just basically, going into an event modeled or event driven architecture where they're reverse engineering what the system is doing based on what log messages they were tracing out. Again, it requires some finesse to not cheat, because that system you can cheat. But it's a very good technique that I found. But it's mostly messy legacy enterprise applications that are hard to test. But I love finding these little shortcuts for these teams, so that they don't start this journey of like, here's everything you need to know. Looks like you're doing everything wrong, and then it's like, and then they're demotivated on day one. Like, why would I do
I
that?
usually don't do that. Like usually it's not exactly that process like that. Like the process is like we go with the team, and then with the team, the first thing is like you put enough people in the team with knowledge so we can split it in pairs, and then
Yeah.
what you ensure is like always someone that knows how the practices can be with
Yeah.
that team, and then it's simpler to do that on the day-to-day basis.
Yeah.
Not only the TDD part, but also like what you were saying, like working effectively with legacy code. Well,
Mhm.
what I refer is like, okay, those skills are skills important, but they are kind of different to like the first practices. If you want to do it from the ground, if you have a new feature to do and you don't know how to do it, then you need to also upskill that at the same time. So what we do
Yep.
is like we save some extra time from the working day, like 4 hours, 2 hours, and what we do is we do a kata, an exercise,
Mhm.
stressing just small things that they need to work or we've seen that are painful, and we try to
Yeah.
measure the pain of the team. And, okay, this is more painful, so
Mhm.
we need this. And if we have like a requirement, okay, before this we need to understand this, and we
Mhm.
do that. And that's more or less how we like to do it, which basically means like we're doing something similar to what you're doing,
Mhm.
uh, to an extent, because I mean, like we try to avoid the bugging as much as possible. Not always is possible, but like we try to avoid it as well,
Mhm.
because we know the pain and what it
Yeah.
means. Uh,
Motivation is a key driver. Like you need to keep the motivation high, and that like everybody essentially, if they're doing TDD for the first time, they will become very like they're constantly at the risk of being demotivated and going back to their old way of doing it, which is going to be very incompatible and very disheartening to everybody else who's sticking with the process, right? So you don't
correct.
want anybody to give up.
And also like keeping like for me the important part is like keeping those small spaces to learn. They also get the knowledge, and they see that they can grow in their careers, not only to
Yeah.
understand of what they're actually doing.
Yeah.
And the pressure in that side is not to finish what they're doing instead of what they're actually doing day to day, which is
Mhm.
like we need to deliver this,
Yeah.
which kind of also is a good encouragement for them to practice what they want to learn. It's like, oh, this is nice, I'm going to try to do it.
Yeah. And also that you can see evidence of it can be learned, and it's hard to learn, like clean code, refactoring, code smells, etc. It's hard to learn, and they can see everybody else struggling. Like it sort of kicks the imposter out of the room if they're struggling with imposter syndrome, because they get to observe that, oh, it's actually hard for everybody, not just me. Like it was a hard concept to learn, but now seeing it out in the open, it's actually clear that, yeah, this actually takes time. There's no shame in not being very good at it from the get-go, especially if you're a self-taught developer, or coming from a different industry and sort of doing a career shift into software. But that you get to do it and experiment and share the experience with your team members of, oh, we've learned this together. It's like, oh, that new refactoring trick that Emmanuel showed us. Let's do that. I think that one applies here. It will make inverting this dependency a lot easier.
And also, it's a really nice way of reducing like when everyone is like the first time doing pay or mobile or sample programming together. The thing is like, okay, I fear to show my weakness.
Yeah.
So you break it down that part too, because it's like, okay, I thought I didn't knew this, but like everyone in the room, as you said, doesn't know it, so it's okay to not know it, and then we can learn it together, and then you start building up the team. So that's like what we were talking before about, like working like in a factory, giving you the things, or working together. That just basically also changed the way that people think about it.
Yeah, that it's not a toy. That it's okay. Like 10 years ago when I started with XP practices, no, 15 years ago almost. When I got when I committed to building a complex feature, the first thing I did was look for a pairing partner. It's like, who would I need to pair intensely in the beginning cycles of building a complex feature, because I need to get the details right, which means a lot of like rapid iteration on different ideas, different architectures, and just to see like how quickly, how big of a problem is this even? What can we do in a day? What can we do in a week? I need evidence of this as soon as possible. And I saw that it was also frowned upon. It was stigmatized to some degree to see, oh, two developers are sitting at the same computer, and it's, oh, they're at the whiteboard, not at the computer, and it gets under your skin. Like those like little glances and conversations, and it's okay to pair. Like it's okay to sit down with your entire team and code something slowly together, as long as it's making like huge amounts of progress and also teaching everybody how the system works. There's nothing positive out of hyper individuating and focusing. And then you produce a lot of code that gets stuck in code review, or gets stuck in like a pull request that marinates on Git for like 2 days, or you miss some key detail and it's missed, but the CI pipeline will check if you're right or not, and then you'll do something else in the meantime. Like that's like going fast is not the antidote. And I realize we did mention the word going faster, but I wouldn't use that the word in that context nowadays. Like the point isn't to go fast, to code fast. The point is to move on important strategic objectives for the company in like a economic fashion, in a timely fashion, without waste. But that doesn't mean that the code was produced very quickly. It's likely that the code was produced very slowly because you had to try a few things and double check, measure twice, cut once, right? Or measure 3 times. Like at the end of the day, clean code and testing, like TDD, it's just double bookkeeping. It's just double booked like accounting. Like you're
It's
making
management.
sure that you understand the business requirements, you're making sure that you understand what you've written, and then you check, hey, if I understood the business requirements, then I've implemented it correctly. And if I've implemented it correctly and I check what it does, it will express my understanding of the business requirements. And if those two things match, then the business people will be happy. Right? And that is a non-trivial exercise, because you have to admit that, what, maybe I misunderstood the ticket, maybe I implemented it wrongly, maybe both, and that's the worst. And then you're looking for like optimizing a for loop, or getting rid of an optional or nullable field, when in reality you misunderstood what the business wanted. Right? And to just be candid that this can happen to everybody and this is normal, and you'll have to say no to a lot of things and experiment with a lot of things. And slower is often better. for these things, but not wasteful, not slow in a processed waste kind of way where you're like just browsing Facebook up and down and or what is this Substack feeds up and down nowadays, right? But slow in the sense that the team is working together and you're making incremental progress in small steps, but you can provably say that, yeah, actually we didn't understand, we invested an hour, now we understand, now we redesigned it, now we tested it, the tests tell us that we are making good progress and it looks like it's going to be done by the end of the day and then we'll have it deployed. And like that's that kind of slow is smooth.
Also, like I think you were mentioning like how you were also mentioning one thing without saying it. Like some of the people think that like software in itself is just delivering features, but it's also like managing risk and understanding the risk we have and reducing the risk. That's also part of our work. And one of the things that like, people don't understand is like we try to see if this is feasible, not feasible, and also try to reduce the unknowns, trying to move safely. That's what we are actually trying to do. It's like I like to say like we're with a torch and darkness, and we're trying to see where we're going. So we try to move safely, so we don't fall off a cliff just because we don't see anything.
Yeah, exactly. Yeah, I always say to my clients that being a great technologist means you also need to be a good poker player. Like you need to use your risk like a budget. Like you need to understand. You need to play the other player, and you need to understand like the basic math of the game you're playing. And the game is software, which means that like you are the least risky part if you look at it that way. The compiler gives you a lot of freedom. Your skills, I like to think that engineers are very smart people. It takes a lot of like interdisciplinary knowledge and experience. Like it's very difficult to just learn it from school and be very good at it. It takes experience, decades of experience, and you're the least risky element. Like engineering, it's the least risky element. It's much more likely that the business got something wrong, or they're asking for a feature that doesn't have market demand, or the market demand was correct but the timeline was not. So it's very likely that because of no fault of your own, you're building a feature that actually got, that took a wrong turn somewhere upstream. And the best benefit that you can give them is to succeed or fail very quickly, right? To optimize the timeline of, I'm not really sure you really want this. So let's try a simple implementation first to verify that you really need this. And if you do really need this, then you want me to invest more time into it. And to take like that's extreme programming in a nutshell. It's like, well, I can't be 100% sure that you actually need this. So I'm not gonna make it perfect. I'm not gonna waste time on it making it perfect. But the more you're insisting on another iteration, the more I'll keep it ready to be refactored, right? And if you only want one iteration, then we can just throw it away. But most people don't, so that's the danger.
That's what I said before. Like the POC that never got thrown away.
Yeah, but POC also has like other connotation of if you're in an agency or consultancy, people actually want like a very lean, waste-free MVP. And the way they communicate that is they say, oh, I want a POC. But a POC is something that you build to validate market demand, so that in case you were wrong, then you don't build it, right? But a POC is something you build to say, oh, yeah, this is worth investing X amount into, so that we can build the software around it. But the point with POCs is that they are built within a weekend or within a week, like a hackathon style POC. That's a POC. If your POC takes a month, that's not a POC. That's somebody cutting corners to build an MVP, and it's probably gonna be.
Or no, or like they tell you it's a POC, you actually build a POC, but then they want to iterate because they think it's a good idea, and then that happened in the past.
Yeah.
Like,
No,
okay,
but if they can, but I always say that mistake is always on the engineering team, because if they can use a POC in production, then it wasn't a POC. Like a POC is I'm wiring together screenshots with like a Google form, and it's like it's like barely surviving, like I don't know, the the equivalent of a Turing test for a reasonable application, right? So it's like a barely an application. So it's
actually that was the case. That was like as a real example. That was the case. It was like an inform that needed to be taken from a data lake, building some information,
I
and
see.
then
Yeah.
But the thing is, like they like it, and it's like, okay, now we want you to build it as an MVP because we need this inform now, and it's like, okay, don't use everything we have. Because the idea is if we could take the information from the data lake and consume it because the information was there or not, and we needed to double check with product.
I see.
Is the information we need or it's not? And then we need this, and it's like,
okay. But in my experience, data scientists do work like that. Like they actually just want one-off transformations, or like a screen once, or a screen once every quarter, or a screen once every
like
yeah. To them, that's not a POC. Like I want it good,
Agreed.
but I'll only need it once. And then next year I'll need it again, but it'll be slightly different. So you have to build it from scratch probably. Anyway, we went a bit off topic.
Yeah. I was gonna say, like, the thing is, like, the product is the one that sometimes want that, and it's like, okay, I can understand that from a data scientist or from that perspective, but like, product needs to be aligned. This is part of the product or not.
I always say, if they keep doing that, let them hire their own engineers. Let's not bother the product engineers with that. That seems to a capability that either needs a platform team or a data science team, and they can probably have some equivalent of a data scientist who also knows a little bit of programming to make that happen. That's a team topologies discussion that I don't want to go into right now. Next time.
Okay, we're a little bit off topic, so yeah, you're right.
Yeah.
We're also over time, so we can close if you want.
But this was a lot of fun. To our live viewers who are still with us, thank you so much for being here. Alberto, thank you for the question. Hope to see you all on the Nick Shoemaker stream with our tech journey tomorrow. It's 4 p.m. Central European time. So that's Madrid time, Berlin time, Belgrade, Ljubljana time, one hour ahead of London. 4 p.m. We're going to have a 2 or 3 hour stream with Nick Shoemaker on how to test Next.js apps with TDD. He's going to build a new feature from scratch, live on stream. It's going to be a lot of fun. If you have any questions, plus, I think there's going to be like 200 people live. So it's going to be a fun experience. There's going to be a lot of fun happening in chat. So if you just want to be part of that live, that's also worth it. There's links in my profile, and I'll be spamming all of you anyway. And you probably know. If you're here, you know. So I'll see you all tomorrow. Emmanuel, thank you so much.
Thanks.
Alberto says, thank you for this amazing conversation. Thank you for the response. Thank you as well, Alberto. Ciao.
Bye. Ciao.